example 2. Here we have the graph of h of x. We don't have the equations, but when we look at this graph, we can see there are 3 pieces because there are 3 different shapes. So we're going to do the same thing here. When we look to evaluate h of negative 2, we're thinking, well, we have to go to where x is negative 2 first. So we go to negative 2, and it looks like that the value for the function will be 4. Part B, h of 6. Well, h of 6, this function ends at x equals 4, so this does not exist. H of negative 6. Well, once again, this function does not begin until a little bit to the right of negative 6 because there's a hole there. So this also does not exist. Part D, h of 3.5. Well, 3.5 is in the middle of 3 and 4, and we have a y value of 2 there on that constant function piece. Part E, h of 1. Well, this is a little tricky at first. Remember, we're going to where x equals 1. Well, x equals 1 has a solid circle at 1. So that is where the function is defined. When x equals 1, we're on that piece that looks like a piece of a parabola, not at the constant function where y equals 2, because there's a hole there. So this is a hole, and this is a solid filled in piece. So this 1, 1 is where the function exists there when x equals 1. So what's the domain of h? Well, reading the graph from left to right, we have a parenthesis to wrap around negative 6 because there's a hole at negative 6. And we have a bracket around 4 because there's a solid circle at 4. So the function begins at negative 6 but doesn't include negative 6, and it ends at 4 and it does include 4. So that's how in interval notation the domain looks. The range of h. So I look at the range by reading from bottom to top, and it looks like I pick up 0 at the origin on the parabola piece, and then as I keep moving up the graph, I stop having any function values at 4 positive, and there's a bracket there because they're between the constant or the parabola function in the middle and the linear function in the left piece. They both reach a maximum value of 4.